All right, this is video 4D. We're going to look at some real-world examples of quadratic problems. So here we have some information about a helicopter. All right, it is flying to drop a supply to or behind the fire lines. At the moment when the helicopter makes the drop, it is 400 feet above the ground. All right, and so the bundle's height in feet, and they tell us that's ht, after a given time in seconds, t, is given by the formula ht equals 400 minus 16t squared. Okay, so first thing I want you to do when we look at these quadratic problems is to think about it in context of the problem. Okay, so all right, ht tells us that this is the height, and t is the time in seconds. Okay, so if I'm substituting a number in for t, that's the time since that bundle has been dropped from the helicopter. All right, and then this over here, ht, is the height, how high the bundle is in the air. So it starts at 400 feet. So I have my little, I'm not going to attempt to draw, but I have a helicopter and they're going to drop this bundle. Okay, and so over here, my y value is how high this bundle is off the ground, and t is the time since it was dropped from the helicopter. So what we're going to do is we're going to use Desmos, all right, to graph these. So the first thing I'm going to do is come over in my Desmos window and I'm going to type it in exactly like it's written. So h parentheses t equals 400 minus 16t, and I want the t to be squared. Okay, and so we have here what just looks like two straight up and down lines. Okay, what I'm going to do is I'm going to zoom out until I can see, even though it's very tiny and very skinny, this is actually a parabola graph. Okay, so if I go back to where we started, what we need to do is change the settings on our window so that we can actually see the parabola shaped graph. Okay, and so what I'm going to do is I'm going to click the little wrench, and here I have my settings. So let's think about what these numbers mean. So on the x-axis, all right, x is the same as t in this case. Okay, that's time. All right, we don't really have negative time. Okay, in this case, we're starting the timer from the time that the helicopter drops the bundle down, so there's no negative time. So I'm going to go ahead and start my x-axis at 0. And for now, we'll leave the max at 10. For now, we'll go from 0 to 10, and let's just see what that looks like, okay? Now, on my y-axis, okay, I know that I'm going to drop it from 400, and it's going to fall down to the ground. Okay, so that means my y-axis can also start at 0. All right, and it needs to go up to at least 400, and what I like to do is just pick a number that's a little bit bigger. So maybe let's go to 415. All right, so now if I look at my graph, I can kind of see half of that parabola shape. And here's the cool thing about Desmos, I can just kind of take this and slide it over to where I want it to be, so now I can see my parabola shape. Okay, so first question that we need to answer is how high will the bundle be after 3 seconds? All right, so t is 3. All right, now you have some options here. Remember we said if we click on the graph, it'll give you some key points. All right, and I could kind of take this guy, and so right now I'm at 2.66. I could kind of slide it and try get to exactly 3. So 3, 256. All right, there's my point. So after 3 seconds, my bundle will be 256 feet off the ground. The other thing that we can do is, remember I showed you guys how to change this from a graph to a table. So if I go back to where I have my graph entered in and click the little gear and change this to a table, all right, they want to know at 3 seconds. So if I put 3 in, it tells me 256. Okay, so at 3 seconds, the height is 256. All right, and then I'm gonna close this table for now. All right, how many seconds will it take until the bundle is 100 feet off the ground? Okay, so this is my little bundle. It gets dropped at 400 and it's falling, 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 300, 200, 100. I want to know right here. Now, here, if I start sliding my little slider, I can't really get to exactly 100 on the dot. It's a decimal number. All right, so what we're going to do is we're going to make another line. All right, and we're going to make the line y equals 100 because we want to know when the height is 100. All right, and now Desmos will tell me exactly where they cross. Okay, so when it's exactly 100 feet, the time is 4.33. So it will take 4.33 seconds for the bundle to fall to 100 feet off the ground. All right, how many seconds will it take for the bundle to reach the ground? All right, well, reaching the ground would be a height of 0. So I'm going to move my graph around, okay, and a height of 0, if I click on my graph, it gives me that point right there because that's an x-intercept. All right, so 5, 0. So that means it will take 5 seconds for the bundle to touch the ground and have a height of 0. Okay, so you got to be good at using Desmos, and you got to be able to think about when they give you these numbers, are these numbers x values or y values? So in this problem, x values were time and y values were height. All right, you have to be able to identify for each problem, what are my x values and what are my y values in context so that you know where to plug things in. All right, and that's it, guys.